Hey everybody, Dr. A here, and in this video we're going to be providing an overview and some background information on the profession of civil engineering. So let's get started. As we get started, you want to write all of this down, write everything I write down, including what's already written here, so you have it, nicely put together in your notes for future reference. So what is civil engineering? Well, civil engineering is a professional engineering field that deals with the design, construction, and upkeep of the physical and natural environment, comma, we're going to put a comma there, including works like roads, bridges, canals, dams, and buildings. The duty of a civil engineer, not engineering, the duty of a civil engineer is to use math and science to design and monitor infrastructure for the betterment of the health, safety, and welfare of the public. Now I'm going to pause here and I'm going to really underline this phrasing, health, safety, and welfare of the public. This is one of the most important aspects of the civil engineering and really any engineering profession. Everything you do as an engineer has to revolve around keeping the public healthy and safety and keeping their welfare on the forefront of your mind. So as an engineer, you're going to be using math and science tools to design systems, and in civil engineering, these are systems involving large-scale infrastructure, while always keeping in mind the health, safety, and welfare of the public. Because it's the public who are going to be utilizing the things you design. And whatever you design has to be done so in a safe manner so we do not put lives at risk of the general population when they are using the things you designed. So that is the most important aspect of any engineering profession. And of course, we're talking about civil engineering specifically. Now, what about environmental engineering? Okay, what is environmental engineering? Well, let's write that definition down. And I promise it's not as long as the civil engineering definition we just wrote down. But environmental engineering is the integration of science and engineering to improve the natural environment to provide healthy water, air, and land for habitation. Now, that habitation could be human habitation, or it could be other plant or wildlife habitation, other organism habitation, but it's habitation in general, and most of the time we consider it for human habitation. Okay, now another aspect of environmental engineering is to remediate pollutions. Okay, so we're going to write that down. Environmental engineering is also concerned with remediating pollution. And of course, we look at a lot of pollution caused by humans, okay? So let me clear up some of this debris that I sprinkled on this page. Okay, so that's environmental engineering. Now, a lot of times we see at a lot of universities in civil engineering and environmental engineering housed within the same department. And in fact, at Christian Brothers University, our department is actually called the Department of Civil and Environmental Engineering. We've kind of bundled them into one umbrella. At other universities, these could be standalone programs. You could have a civil engineering program or civil engineering department that is more separated from environmental engineering. But both of these professions tend to work together. Okay. Now you saw a little peek of my next question. What is architecture? Okay. So architecture is another profession that works alongside with civil engineering professionals and environmental engineering professionals. So as a civil engineer, you need to be familiar with architecture and the things that architects work on, because oftentimes as a civil engineer, you will work with architects. So let's define architecture. Architecture is the process of planning, designing, and constructing infrastructure. Let's see if I can spell that right. Infrastructure that involves the more aesthetics or artistic elements of a project. So, for example, architects will be more concerned and interested in the aesthetics or the artistic aspects of an infrastructure design, but it is more than that. It's not just how your infrastructure looks that the architects are concerned with. Architects are also very concerned with the design of the overall functionality of infrastructure projects. So for example, if you are designing a building as a civil engineer, as a civil structural engineer, you may be involved with designing a building. The architect working on the project will not only be interested in what the general aesthetic of the building looks like or how the building looks, but the architect would be concerned with how many columns are in the building, where are those columns located in the building, and do those columns interfere with the overall usage of the building. So architecture is another professional program that is very important. Architects typically do not utilize applied math and science to the same level that engineers do. So an architect would be someone who is less interested in the math and the science and the calculations behind how something is going to be designed, whereas the engineers are the ones who are utilizing more of the applied math and science behind how a project is going to be designed and then eventually built. But they all work together, okay? So let's scroll on down. I have another question here. What are the primary disciplines that we see within civil engineering? So civil engineering is a big umbrella, and it has several different subfields or concentrations within it. So in most civil engineering programs at universities, you're going to take a couple of different courses in each of these disciplines that we're about to list here. So what are they? If you want to try to name them on your own, maybe pause the video and see if you can do it without watching, but I'm about to list them right now. One of the disciplines in civil engineering is called structural engineering. Structural engineering. Structural engineering uses a lot of math and physics to design structures like buildings and bridges, okay? Another discipline in civil engineering is called transportation engineering. Transportation engineering is the field within civil engineering that uses a lot of math and usually a lot of physics to design roadways, traffic signals, intersections, railway design, basically anything that involves transporting things, physically transporting things, and the conduits to which things are transported, like roadways. That's transportation engineering. The other, another subdiscipline of civil engineering is called water resource engineering. So water resource engineering deals with the math and the physics behind moving water and designing systems to manage moving water. So that could be pipe systems, pumps, that could be evaluating the flow of water in rivers and lakes. All of that falls within water resource engineering. Another discipline of civil engineering is called geotechnical engineering. Geotechnical engineering. This is the branch of civil engineering that uses a lot of math and physics to evaluate soil and soil properties, because everything that a civil engineer is going to design has to be built, and it's going to have to be anchored into the ground, into soil. So geotechnical engineer is a civil engineer who specializes in evaluating soil properties for the purposes of building things within it. And then the fifth main discipline in civil engineering, of course, is what we've already kind of talked about, and that's environmental engineering. Now, there are some other disciplines that people consider a part of civil engineering as well, but these are the five most popular. These are the five most popular, most common, and most discussed subdisciplines of civil engineering, okay? So let's scroll on down. The last question I have here is, what is ABET? A-B-E-T. What is this acronym that I'm calling ABET? Well, ABET is an accreditation body that accredits engineering programs. Now, ABET also accredits other types of programs like computer science, some natural science programs, some technology programs. But for our purposes, since we're talking about engineering and specifically civil engineering, that's how I'm going to define it. So ABET is an accrediting body that holds engineering programs accountable for minimal acceptable standards of the profession when it comes to the professors educating students. Okay, so it's an acronym that stands for Accreditation Board for Engineering and Technology. So let's write that down. It stands for Accreditation Board for Engineering and Technology. But we typically just shorten it to ABET, okay? So having an ABET accredited engineering degree allows students to do what? So this allows students to take the fundamentals of engineering, which we call the FE exam, and the principles and practice of engineering, which we call the PE exam. Okay, so the FE exam and the PE exam are a two-step engineering licensure process. All right, so to become an actual engineer and to have the title of engineer, you have to pass both of these exams. Typically, people take the FE exam at the end of their senior year in undergraduate or right after they graduate and they have their bachelor's degree. So you typically, the typical student or typical recent graduate will take the FE exam, maybe when they're in their early 20s, somewhere between 21 and 23. The principles and practice of engineering exam, the PE exam, is another exam that people take about 4 years after they graduate with their bachelor's degree, although every state will have some different rules and allowances for when you can take it. But a lot of people take that PE exam when they're in their mid to late 20s, after they've worked for about 4 years or so in industry as a practicing engineer in training, okay? So the FE exam is a 5.5 hour long exam, and the PE exam is an 8-hour exam. Now, before you panic, don't worry. ABET accredited engineering programs get you ready for these exams, okay? So if you are in an ABET accredited civil engineering program at a university, that program, a big part of what it does is to get you ready to take these exams, especially the FE exam, because that's the exam you a lot of times take as a student when you're finishing up school. So a big part of our jobs as professors is to teach you the technical material on engineering, as well as to teach you how to be an engineer so you can be successful on these exams. So at our university, at Christian Brothers University, we have a very high pass rate on the FE exam on first-time attempts. So that's a testament to what our professors at CBU try to do and instill for our students, okay? So after you pass both of these exams, your PE exam being the follow-up exam, you become a licensed professional engineer, okay? And so getting these licensures, again, it's required if you're going to become an actual licensed engineer. So these exams are similar to the CPA exam that accountants have to take. It's kind of similar to medical board exams. It's kind of similar to the bar exam that lawyers have to take to become licensed in that profession. Okay, so our program at CBU prides itself on the great job it does, its professors do, in preparing the students for these exams to become licensed engineers. So that's going to conclude this video as some general information about what civil engineering is as a profession and all of its important components. If you found this video helpful, please hit like and subscribe.